Okay, let's begin. Voices off, and lesson 892 is solving systems of equations by substitution, part 1. What's our objective, class? Get ready?
Solving systems of equations by substitution, part 1.
Very good. Today we're going to solve two equations at the same time. We call it solving simultaneously. Instead of by graphing, remember a couple weeks ago we did graphing and we found the point where they intersected? Today we're not going to graph them, but I can show you a really cool way to solve by substitution. And there's going to be a part 1 and a part 2. Today you'll learn part 1. So let's take a look at this example. In the cash register, there were $3.50 in nickels and dimes. If there were 10 more nickels than dimes, how many dimes were there? So there's a couple parts going on. There's a value part. When I see nickels and dimes, I think, oh yeah, it's 5 cents for every nickel. And I see dimes, I think, oh yeah, that's 10 cents for every dime. The total value is $3.50. So that's one of my equations. Now the other equation, just hold on. The other equation talks about the number of nickels and dimes, and it says there's 10 more nickels than dimes. So in my mind, a lot of students have struggle on this part, because there's 10 more nickels than dimes. So I have to think, okay, so if I had 6 dimes, how many nickels would I have? So there's 10 more nickels than there are dimes. AJ? 16 nickels. Okay, so that helps me formulate an idea. The number of nickels is whatever the number of dimes is plus 10. Okay, so the wording is weird though. It's 10 more nickels than dimes, but the nickels is here. Okay, so whatever the nickels is, it's 10 more than that, 10 more than the number of dimes. Okay, so that's how you get your nickels. So there's our two equations. We now have a system of equations. And so we're going to take that system, shrink it a little bit. We're going to take this system and we're going to solve it with the substitution method. Why? Two reasons. One, I don't want to graph a big number. I don't want a bunch of tick marks out to 300 and something. Also, I notice one of the equations is already solved for one variable. That's the key thing to look for. If one equation is solved for one variable already, the easiest, best method is to use the substitution method. What method? Get ready?
Substitution.
Substitution method. So here's how you do it. First step, take the second equation, or the equation that's not isolated. In this case, it's 5n. Instead of the n, I'm going to put a space holder for n. And I'm going to copy down the rest. Okay, so again, I'm taking that second equation, the one that's not isolated, and I'm just going to rewrite it. Instead of the n, though, do I know what n is? I actually know what n is. It's d plus 10. I don't know the exact number, but I know n is d plus 10. If I said n was 16, could I put 16 here? If I said n was 38, could I put 38 here? Okay, so we don't know what it is, but I know that it's d plus 10. So we're going to take d plus 10, we're going to put it in for n. d plus 10. Now, that's the only new thing you're learning today. Just that step. That's the substitution step. What step is that? Get ready?
Substitution.
Substitution. So now I distribute. Oops, I ended up on the wrong. I got red on black. So now I'm going to go 5 times d plus 5 times 10, which is 50, plus 10d equals 350. Combining like terms, I have a positive 5d and a positive 10d, which is 15 dimes, plus 50 equals 350. And now I need to solve here by, my other color. Isolating d, we're going to peel away the layers from farthest away, then we work inwards to the d. So I'm going to get rid of the 50. Keep a balanced equations. Those are eliminated, and I get 15d equals 300. Can I solve for d mentally now?
Mm-hmm.
What would that be, Alex? 20. Very good. I have a mystery marker. Here it is. Okay. So d equals 20. 20 dimes. Am I done?
Yeah.
20 dimes? I know there's 20 dimes. There's a little bit more to it. So be careful. I've got to find n and d. So since I know that there's 20 dimes, can I come up in this equation and put a 20 in for dimes? And so, the number of nickels would be 10 more than that. So the number of nickels is, get ready?
30.
30, good. Thank you for calculating mentally and staying with me. All right, questions? Kenna?
I don't quite understand how you got
This part?
the second, no. So there's two equations, and then there's the n equals g plus 10. How do you get the other one, that one?
Oh, this one. You know what they did is they took the 5 cents for each nickel, 10 cents for each dime, and they changed them all into pennies instead of dollars. So you know how we'd use 0.05 to say 5 cents? They just moved the decimal twice. Once, twice, once, twice, once, twice. Okay, so the value of all the nickels that are 5 cents each and all the dimes that are 10 cents each would be $3.50. Make sense? Okay, I'm glad you asked. Your name just went blank. Jacob.
Yes!
Okay.
Okay, so could you just why would you need to use this method when you could just use, the graphing method, like in the other one that we did?
Well, it'd probably have everything to do with that number. It's too big. I don't want to do that. Mark's
No,
not
not like that graphing method, like, I see.
just too big of numbers. And knowing that this one's already isolated makes it really quick to just substitute it in. I don't have to worry about a graph, and I just combine like terms, distribute, and solve. Okay, we're going to do another example, but first, before we do that, we're going to summarize our steps. So if you want to take abbreviated notes on these steps, make sure you know the steps for the substitution method. Step 1, isolate one of the variables. What's step 1? Get ready?
Isolate one of the variables.
Let's do that one more time. Make sure everyone's repeating back. Isolate one of the variables. What?
Isolate one of the variables.
Very good. It was already done for us in that case. All right. Number 2, substitute. What's step 2? Get ready? Substitute. We took one variable and we put it into the other equation, and then we solved. All right. Step 3 is to find the other variable by substitution. So we're going to say substitute. Let's see, that's kind of long. So we're going to say solve for the other variable. What's step 3? Get ready?
Solve for the other variable.
Good. Solve for the other variable. Step 4 is to check. And you know what? We didn't do our check step. So we're going to do it on our next one. We'll do our check step. Step 4 is check. What is step 4? Get ready?
Check.
Check. Very good. Let's try. I'm going to call on students this time to really help us. Do you guys need a little bit more time on those steps?
No.
I think we did do the check.
We checked it in the
29
D plus 10, but we didn't do the value check in the value equation. All right, we'll do it here. Hey, Denise participated in a marathon, a race, by the way, they're 26 miles. She ran part of the way, averaging 7 miles per hour, and walked part of the way, averaging 3 miles per hour. It took her 6 hours to complete the marathon. So I'm going to pause right there. We have distance information, and we have a time, information. So the time was 6 hours, right? 6 hours. And she ran and she walked, right? But she also had a distance to go. So we know there's a distance information. Well, if you know the distance formula, the distance is rate times time. Well, we know a rate. 7 miles for running. 7 miles per hour times the number of, or the hours ran. 3 miles per hour times the number of hours walked. It's going to add up to her distance. So if you see, if there's a rate times a time, a rate times a time, that's going to give you your total distance. So here's our two equations. Sometimes they give them to you anyway, so in this case they gave them, so we get to just start there. But wait a minute. Didn't we write running plus walking added up to 6 hours? Why do they have W equals 6 minus R? Who sees why? Why does theirs look different from the one that we came up with? Spencer?
Well, it's just for free isolation. They're just trying to isolate a variable.
Perfect. They isolated this variable, and we'd be really quick to do that. And they could have isolated R. It wouldn't really matter. They just picked W. So since W is isolated, step 1 would be to substitute this variable into the other equation. So I'm going to rewrite it, and I need help on how to do that. Let's go, Emmy.
wouldn't it be like 6 minus
Yep. Okay, good. Keep going. What else do I write? Keep going right here. So we just wrote the 3W. Keep going.
plus 7R equals 6.
Perfect. Okay, make sure everyone's like really focused here. What did Mrs. Boone just do? I rewrote the equation that had both variables in it. And instead of a W, I wrote what W equals. If I said W equaled 29, I could put a 29 here. But we don't know what it equals, but it is 6 minus R, so I put 6 minus R. Okay, we're going to distribute. What do I write? Dakota.
3 times 6, which would be 12, and then...
Close.
Oh, 18.
18, that's right. We just had spring break.
Jeez.
And then?
And then negative 3R.
Good. Okay, keep going.
Plus 7R equals 26.
Good. What's my next step? Maddie.
Combine. And that would be positive 4R.
Ah, I love it. You gotta write the first try. Negative 3, you're here. And then you add 7, you're gonna be over there. So it's positive. Copy on your 18. 26. Hey, how do I isolate R from here? Kenzie. Isolate R. Perfect. Okay, I get 4R equals 8. And what does R equal? Hiram?
2.
R equals 2. So I know there was 2, this is our time, right? Time spent running, time spent walking. There were 2 hours spent running. 2 hours. How much time was spent walking? Lucas? 4. It had to be 4, right? So I know my 2 solutions, hours, I would box those and I would make sure to get both answers. But I haven't checked this equation. Do these work in this equation? Because the answer has to work in both equations. So you're going to substitute them both in. R equals 2. W equals 4. And I put a question mark. Does that really equal 26? There's 14. There's 12. Does it equal 26? Yes, it does. We put a check mark. 26 equals 26, and then we know we got it. Any questions about substitution method? You guys get to practice them on your practice set. Take a stand-up break. We're on 8, 10, 20 seconds. That was kind of a shorter one.